let's take a look at this first problem of this lesson 10. Okay, to get into the National Honor Society, Mark has to have an A average in biology. His test scores so far are 86, 91, 89, 93. He's pretty much there. An A is a 90, at least a 90 average. He has one test left. What is the minimum score he can get on the last test in order to get into the National Honor Society? Now understand, to get an A, you have to have at least a 90. What does that word "at least" mean? That's what we're going to discuss for the next couple of slides. So let's take a look at this your next problem in your workbook. All right. So let's translate the following. I'm going to do the first two, and I'm going to ask you to go to your workbook to do 3 through 6. Okay. First, it's x is less than 5. X is less than 5. If you recall from, I think it was mod 1 or 2, I believe it was mod 1, we talked about this. When it says is less than, that's the symbol. That's the x is less than 5. That's the inequality symbol. If it was just the word less than, that would be switching the order and subtraction. So we have to make sure we understand that the word is tells us it's the inequality symbol. Number 2 says x less than 5, and that's the one I was referring to. X less than 5. It has no is. This is subtraction. And remember, less than is that ding, 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 that keyword phrase that tells us to switch the order. So this is 5 minus x. Make sure you can see the difference between these two because it's a big difference. It means something totally different. Okay? I'm going to do one more with you. Then I'm going to ask you to go to your workbook to do the next 3. Okay? A number is at least 5. At least 5. Let's talk about this phrase, at least. If I have at least $5 in my pocket, what does that really mean? If I have at least $5 in my pocket, it means I have $5 or more. So a number is at least 5. That means it's got to be greater than or equal to 5. So at least is that symbol is greater than or equal to. So now I'd like you to take a look at 4 through 6, stop the video, do those 3 problems, put them into symbols, and then we'll check them when we get back. Okay, let's take a look at these 3. A number is at most 5. Okay, if I have at most $5 in my pocket, how much does that mean I have? If I have at most $5, that means that's the highest amount I can have. So that means that I have less than or equal to 5. So at most is the symbol is less than or equal to. All right? A number is not more than 5. Now we talked a little bit about this. I don't know, mods ago. I'm not sure what mod, 2, 3, 4, I can't even remember anymore. But a number is not more than 5. We said that there was a trichotomy of numbers. That means a number can only have one of 3 relationships with each other. A number could be greater than a number, it could be less than a number, or it could be equal to a number. Well, if it's not more than a number, that leaves 2. That means it can either be equal to the number or less than the number. So a number is not more than 5 means that it could be less than or equal to 5. So not more than is that symbol is less than or equal to. Pretty cool. Same thing here. It's trichotomy. It says it's not less than. Well, if you're not less than, you could either be greater than or you could be equal to. So x is greater than or equal to 5. So is not less than is that symbol is greater than or equal to 5. I hope you did okay with those. Okay, for this next question, I'd like you to go to your workbook and answer these questions. Please do that. Stop the video, go to your workbook, jot down the answers, and then click the video back and we'll continue. All right, let's see how you did here. It says x represents any real number. I hope that didn't make you crazy. Remember, any real number could be any integer, any decimal, any fraction, any number. The only numbers it doesn't have are something we call imaginary numbers, which you don't even know about until we get into intermediate algebra. Okay, but x is less than or equal to 5. That means a number is going to be less than or equal to 5. Okay, well, the first question says, what is the maximum value of x? What is the biggest number x can be? Well, if x can be anything less than or equal to 5, think about this on a number line. Here's negative 5, here's negative 4, right? And here's 0, here's 1, okay? And then I'm going to put 5 over here. Here's 5 over here. I know x has to be less than or equal to 5. So it's anything below this. So what's the maximum value? 5 is the maximum value you can be for this. What is the minimum value? Well, we just said it could be anything lower than this. So there is no minimum value. There is no minimum value. Okay? Would my answer change if this said x is less than 5 instead of x is less than or equal to 5? Well, if it was x is less than 5, then the maximum value can't be 5 because you can't be including 5 because this equal to says include 5. So that means you can be 4.9999999. I can't really even say that number. And because I can't say that number, we actually use some different notation that we're going to talk about. So it does change the answer. A would not be 5. It would be something very close to 5 but not touching 5. Okay? And there would be no minimum value again. And of course, since I can't say that number, less than 5, 4.999, I can't say that number that's right below 5 because it goes on forever, remember, is we have some new notation. So let's look at that. Okay, so looking at your next problem in your workbook, or your next slide, we see that we're going to graph some of these. So graph on the real numbers. I'm going to graph these for you, and I'm going to show you what they mean. So give me a second, and I'll write down the first couple of problems. All right, this looks really kind of weird. This is called a brace. You know that already. This X actually stands for all X. This line stands for the word such that, or words, or phrase, I guess I should say, such that. And this is called the condition. You don't really have to know all of that. In a way, you don't have to, I'm never going to say, what does this stand for, what does this stand for? But you have to understand what it means. What this is saying, okay, in math talk, is for all x, okay, and it says graph on a real number. So for all x, for all real numbers, such that the real number is less than 2. That's what that's saying. It's called set notation, okay? For all x, such that, so you want all the x's or all the real numbers that are less than 2. That's what it's telling you. You want all the real numbers that are less than 2. So here's how you do that. Now remember what we said, okay? We have infinitely many numbers less than 2. We are not including the 2. So the maximum number is 1.999999 something. Okay, well, here's how we graph that. Okay, to graph that, and of course you'd have all your numbers here, you'd have numbers on this side, but the only ones we care about are all the numbers less than 2. We're not including the 2, so what we do is we put an open circle on the 2, okay, and we draw an arrow. All the numbers less than 2. These are all the numbers less than 2. 0, -1. These are all the numbers, 1, all the numbers. And whatever I graph, all these numbers are graphed. And I just make an arrow going this way. And that's all the real numbers less than 2. So when I don't want to include the 2, I use an open circle. In intermediate algebra, you'll see some different kind of notation for this. But this is called set notation. All the real numbers less than 2, and here they are graphed. And I can pick one. The number 1, yep, that's graphed, so 1. Is 1 less than 2? Yes. -2, is -2 less than 2? Yes, so I can check it. I'm not including the 2. How do I know that? Because it's an open circle. So when I'm not including that endpoint, okay, that's called the endpoint. When I'm not including the endpoint, okay, I have an open circle. So let's take a look at this one. Let's see how this one's different. Let's look at the condition. I want all the real numbers less than or equal to 2. Well, how this is different is you still want all the numbers less than 2, but now you also want 2. So since you also want 2, you make a closed circle on 2. That means keep me, I'm part of the set. I'm part of the set, keep me. So we want all, and of course all the other numbers here are graphed. The numbers that aren't graphed are the 3, the 4, all of those, all the decimals and fractions this way, because we want the numbers less than 2. All the real numbers less than or equal to 2, and that's how that's graphed. And now this one, I have to be honest, if I were you, I would rewrite this. I think it's easier to see what you want if you rewrite it so the x is first, just like these conditions. So I'm going to rewrite this as x. Read like you're a dyslexic. This works for me because I'm dyslexic. X is less than -4. X is less than -4. Pointy part is pointing to the x. X is less than -4. That makes it easy for me to graph that. I'm not including the -4. Okay, we know the other numbers are here. Okay, x is less than -4. I'm not including it. I put an open circle there. Less than -4. Remember, less than is to the left. Less than is to the left. The left of the number line is less. Remember that from a couple of mods ago? And here's all the numbers less than -4. I can prove that to you by picking a number that I've graphed. -5. -4.5 if I want. -5. -4 is greater than -5. Yes, that's true. So I can prove that to you. So that's how you graph these. And it's just a coincidence that they're all going to the left. Okay, that doesn't always happen, as you'll see when we do 4, 5, and 6. I thought I was going to let you do 4 and 5 and 6, but the more I think about it, the more I'm going to do them. So we're going to come back and do 4, 5, and 6. All right, let's take a look at 4. Again, the condition, x is greater than or equal to 0. All the real numbers such that my real numbers are greater than or equal to 0. So I'm including the 0 here. So it's going to be a closed circle. So here we go. Remember, as you go to the left, you get less. Okay, here we go. X is greater than or equal to 0. If your numbers are greater than 0, we're talking about the 1, the 2, the 3. So we have to make our arrow point in that direction. Okay, here we go. That's it. X is greater than or equal to 0. Kind of easy. All right, this one is unique. This is called a double inequality because it's got two inequalities. Same thing here. This has got two inequality symbols. It's called a double inequality. Okay, I can say this by going -2 is less than or equal to x, which is less than 5. I hate that, but let me tell you what this actually means. This actually means, reading the x first, x is greater than or equal to, because the greater than, right? Open part is to the x. X is greater than or equal to -2. And, I know you don't see the and, but the and is there. X is less than 5. When you write and this just says it in your workbook under the helpful tips, when you write an inequality like this that has two inequalities, okay, this is called compact form. Even though you don't see the word and, it's there. How do I know it's there? Because my smallest number is first, my variable's in the middle, okay, and all the inequalities point left. That's called standard form. That's called standard form or compact form. That's called compact form. Instead of writing something this big, we make it smaller, we compact it. And that's what this means. X is greater than or equal to -2, and x is less than 5. And you can say it that way, but I'm going to tell you how I like to say it. I like to say, and this is in your helpful tips, so I'm not going to write this down, okay? Do you see that the x is in between these two numbers? I like to say all the real numbers between -2 and 5, because that way it's very simple for me to get a number. -3, sorry, not -3, 3, 0, -1. Those are numbers that are between -2 and 5. I think it's the easiest way to see it, because the x is between them. But remember, smallest number first, variable in the middle, everything points left. Okay, so let me show you how to graph this. It's very simple. Okay, remember, you never put the x on your graph, remember. Okay, here's -2, here's -3, here's 0, here's 5, here's 6 if you care. I mean, all those numbers are there, right? We don't have to write them all down, but they're all there. Okay, this is all the real numbers between -2 and 5. We are including the -2 because there's that little equal to part. So we're including -2, so it gets a closed dot. We're not including the 5 because there's no equal to. It just says less than 5. So we're not including the 5. So it gets an open dot, open circle. And then you want everything between there. And there you go. That's how you graph it. It's very simple. And notice I can prove that by taking any number that I've graphed right here. Say the number 1. Is 1 between -2 and 5? Yes. Or if you rather. Is 1 greater than or equal to -2? Yes. And it's got to be yes for both. And is 1 less than 5? Yes. So that works. But I like all the real numbers between -2 and 5. It makes it easy to tell what numbers I'm talking about. So this is a double inequality. It happens to be an and. You don't see the and, but it's called compact form. This is a double inequality or. I know that's surprising since it says the word or. When it says the word or, it's an or graph. Okay, now here's the deal with this graph. Whenever you see an or graph, it's going to say the word or, and generally it will look like this. Or graphs go apart. And graph kind of comes together. Or graphs, because I can be this or this. Watch what I mean. Okay, Here's your 0. Here's your -3. Here's your 4. It's kind of like putting two inequalities on the same graph. You want all the real numbers less than -3. Okay? Well, -3 you're not including because it doesn't have a little equal to. Less than, the numbers less than are to the left, -4, -5, -6, -6.2159. Or x is greater than 4. Well, the numbers greater than 4 are this way. Greater than 4, I'm not including the 4, but you want all the numbers greater than 4. And generally, it's got this gap right here in the middle somewhere. So that's how you graph these. And again, compact form, variable in the middle, smallest number first, everything, all inequality symbols point left. Okay? And under the helpful tip that you see, the first thing you notice it says, if you have this kind of symbol with a little equal to on the bottom, then you're going to have a closed circle. Closed circle. Without it, you're going to get an open circle. So these are open circles. And then, of course, it talks about the compact form. Okay, so that takes care of that. We're gonna look at some more in a second. All right, I'm kind of looking like this because I want to make sure you get the point of this problem. It says, look at each of the following, determine whether they make sense. Explain your answer. Okay, let me explain what I mean by explain whether they make sense. This to me, now of course, this is not compact form. Here's why it's not. Because the smallest number is not first. But does it even make sense is the question. Well, what this is supposed to mean is, read the variable first, x. X is greater than 7, and x is less than 4. That's what it says. Well, can there be a number that's greater than 7 and less than 4? No, because there's no, if a number is greater than 7, it can't be less than 4 at the same time. So this doesn't even make sense. So, no sense. Okay? This doesn't even make sense. Okay, it's not in compact form. If it wasn't compact form, it would make sense. But compact form, I didn't ask you about compact form really, I'm just talking about it because you don't have to be in compact form to make sense. We'll look for more examples of that. But let's look at this first one. This is clearly makes sense, and I don't even have to think about it, but I'm going to show you what I mean. Because this is compact form. Smallest number first, variable in the middle, everything's points left. But let me explain to you why it does make sense. X is greater than -3, and x is less than 2. Can we find numbers that are greater than -3? Greater than -3. If here's -3. Here are numbers that are greater than 3, but they have to be less than 2 at the same time. They have to be less than 2 at the same time. Can we find numbers that are greater than -3 and less than? Of course we can. Of course we can. There's infinitely many numbers. So this makes sense. Not only does it make sense, it is compact form. So I'm going to address both of those issues. Compact form. Almost wrote down issues. Okay, let's take a look at this one. This says x is less than 6 and x is less than 3. Remember, if I don't see the word, it's assumed to be an and. Here's the problem with this. This does make sense. It makes sense because I can pick numbers that are less than 6 and less than 3 at the same time. But truly, what do they have to be? If a number's less than 6 and less than 3 at the same time, don't the numbers have to be less than 3? Think about that. Here's 6. Here's 5. Here's 4. Here's 3. Here's 2. You get my drift, right? Okay. They have to be less than 6. Well, it can't be a 5 or anything in between here because it's not less than 3. To fit in both of these categories, it must be less than 3. So to me, I wouldn't even write this because I would just say this is the same as x must be less than 3. So it makes sense, but why would I even bother using anything like this when I could just say it's the same as x is less than 3? I would just use that instead of this big thing. So I just want you to understand what this is supposed to mean if you don't see it. It's supposed to mean an and. An and means at the same time both of the inequalities must work. Okay? So that's 1, 2, and 3. Now if you would try 4 and 5, just talk about whether they make sense or not, and if that's what you would write, or if it doesn't make sense at all. Okay? And then we'll come back and look at them. All right, how'd you do? I'm going to turn this around and make it say what it's supposed to say with the and. X is less than -5, and x is greater than 4. Okay, Does this make any sense? Can you have a number less than negative 5 and greater than 4 at the same time? Nope. This one plain makes no sense. We don't have an answer in here. No numbers fit in that set. Okay? What about this one? Let's look closely at this one. This is x is less than 4 and x is greater than 0. Do we have numbers that are less than 4 and greater than 0? Can you think of any? 1, 2, 3, 2.5, 2 2/3. So this does make sense. This does make sense. However, it's not compact form. And it's not compact form because the smallest number is not first and the inequalities don't point to the left, okay? So that's why it's not compact form, but it does make sense. But you will never see this anywhere in any textbook. No mathematician even recognizes this because compact form is what they recognize. Variable in the middle, smallest number first, all inequalities point left. That's what they recognize. Because when we have that, watch, smallest number first, let's even do a positive 3. Smallest number first, variable in the middle, all inequalities point left. When you have that, we can now say, well, we want all the numbers greater than 3 and less than 0 at the same time, or all the real numbers between, oh, what did I do? That's bad, huh? Because that wasn't, here we go, let's fix that. Smallest number first, thank you. Now we can say all the real numbers between 3 and 6. X can be greater than 3 and less than or equal to 6 at the same time. When I had 0 there, that wasn't so. I apologize. I had 0 there at first. X can't be greater than 3 and less than 0 at the same time. That does not work. I apologize. But if I put my 6 there, it now works. X can be greater than 3 and less than or equal to 6. Okay? What this says is all the real numbers between 3 and 6, including the 6. What this says is all the real numbers between 3 and 6. I'm not including any. How we can say this is all the real numbers between 3 and 6 inclusive. Inclusive means include them both. Include both endpoints. Okay? So all the real numbers between, variable in the middle, smallest number first, all inequality symbols point left. So let's take a look at some words and put them into symbols. All right, let's look at this first one. All the real numbers between, here's that word between, 0 and 6 inclusive. That means compact form, baby, because it says between. Okay, so all the real numbers between 0 and 6, smallest number first, variable in the middle, all inequalities point left. I don't even have to think about it, but it says inclusive. Since it says inclusive, that means I need these little equal to's in there. So that's number 1. So that's all it takes. Once it says that word between, I know what's going on. Okay? So that all I want you to do with 2 and 3 is put them into symbols. So stop the video, put those into symbols, and then click back when you're ready. All right, here we go. Let's see how you did. All the real numbers between -8 and 2. -8 and 2. Smallest number first, variable in the middle, all inequalities point left. Okay, and now it just says between, so I'm not including either number. So if I said, give me the numbers between 1 and 3, give me, let's say, give me the integers between 1 and 3, the answer would only be 2, because I'm not including 1 and 3. If I say numbers, then we're in a pickle, because then we have fractions and decimals and irrational numbers. So, but this is it, all the real numbers between -8 and 2. Okay? Let's take a look at number 3. In number 3, all the real numbers less than 0, or, okay, that means I got to write this down, all the real numbers less than 0, or, because remember with an or, we have to see the or, greater than 7. Greater than 7. Greater than 7. I need 2 x's. They need to be 2 separate inequalities. So x is less than 0, or x is greater than 7. And since they're an or, there shouldn't be anything that we could put in both sets. You're either going to be less than 0 or you're going to be greater than 7. Okay, and that's it. So that takes care of putting those into symbols. All right, you want to do these by inspection. What does that mean? That means I don't want to do these by solving, dividing, and I just want to think about it, okay? All right, this says 2 times some number must be greater than or equal to 8. So think about what numbers that could be. Well, 2 times 2 would give me 4. 4 is not greater than 8, so I think I'm going to have to go higher than 2. 2 times 3 is 6. 6 is greater than 8. That doesn't work. 2 times 4, 2 times 4. 2 times 4 is 8. 8 is greater than or equal to 8. That's true, because you can be equal to 8. So we know you can be 8. I'm sorry, we know you can be 4. We just said 4. 2 times 4. Could you be 5? 2 times 5. Yep. So it's anything greater than or equal to 4. That's what we know works there. Okay? I never want you to do this again. I just want to show you something. Let's take a look at this. All right. Negative 2 times something has to be less than or equal to 8. Let's think about that. So negative 2. Let's go negative 2 times, well, we know 4 will give me 8. So negative 2 times 4, negative 2 times 4, negative 2 times 4 would give me negative 8, and negative 8 is definitely less than or equal to 8, so that works. What about negative 2 times 3? That'll give me 6. So let's see what I got here. 0, 1, 2, 3, 4. We're saying 4 works. Well, does 3.5 work? Or any numbers in between here? Let's see. Negative 2 times 3.5 is negative 7.5. That'll work. Does 2 work? Negative 2 times 2 is negative 4. That'll work. Does 0 work? Negative 2 times 0. Negative 2 times 0 is 0. Is that less than or equal to 8? That works. 5. Does 5 work? 5 works. Negative 2 times 5. 5 works. So all of these work here. Does 10 work? Yes, all of these work because they're all being negative, so they all work. All the positive numbers will work. So how about the negative numbers? All the positive numbers, because a negative times a positive will be a negative, so they'll all work, all the positive numbers. How about negative 1? 2 times negative 1, that would be 2. That'll work. How about 2? Negative 2 times 2, that'll be negative 2 times negative 2. That'll be 4. That'll work. How about negative 3? Negative 2, oh, well, how annoying, but let's keep going for a minute. Negative 2 times negative 3 is 6. That'll work. How about negative 4? Negative 2, and of course then everything in between will work. Negative 2 times negative 4 is 8. 8 will work. That'll work. How about 5? Negative 2 times negative 5. How about negative 2 times negative 5? That's positive 10. That won't work. So what we have working is everything greater than or equal to negative 4. So this is what works. Greater than or equal to negative 4. But that's bizarre. We never want to do that again. That's ridiculous. Let's take a look at how we can do this a little easier. Let's take a look at this problem right here. Remember, the answer was 4. Well, can you get 4 another way? Sure, you can get 4 just by dividing, like you would if that was an equal. So all you do is divide, get x is greater than or equal to 4. That was the answer. You're done. And let me explain to you the check here. This is an inequality, but this inequality has 2 parts. It's not a double inequality. There's not 2 inequality symbols. It's one inequality that has 2 parts, a greater than part and a less than part. So let me explain to you what you have to do. This is really important. You have to have 2 checks because there are 2 parts. You must check a number that's equal to 4, and then you must check the number that is greater than 4. You have to check both the parts. Now, the number that's equal, remember, we solved this like it was an equal. So the number this number right here called the endpoint, that number will make the 2 sides of the inequality equal. Watch what I mean. Right? That's what you would do. 2x is greater than or equal to 8. You'd go 2 times, sorry, not 2. X is 4. I apologize. 2 times 4 is 8. 8 is greater than or equal to 8. So this right here, the endpoint, is going to make you equal. Okay, your 2 sides equal. Now I got to check a number greater than 4. What number greater than 4? Any number you want. You can check 4.1. I don't know why you would, but you could. Check 5. You can check 10. You can check any number you want. 50. It doesn't matter. So you might want to check x equals, I don't know, 10. Check in the original. 2 times 10 is greater than or equal to 8. That's 20 is greater than or equal to 8, and that's true. You want to make sure, what you want to do is you want to make sure that your inequality is pointing in the same direction. Because don't think that all you do is copy this down. That may not always be true. We haven't proved that. So let's take a look at this one. Well, I could prove it in this one. You do get negative 4 when you divide by negative 2, but what happened to the inequality here? Look what we did. All I did, I know I pretended to try these numbers, but all I really did was divide. I got my negative 4, but look what happened. We had to flip the inequality symbol. Why did we have to flip the inequality symbol? Here's why. I just want to show you something really quick, really simple. I want to take these numbers. 8 is greater than 6. This is a true statement. Now I want to ask you to add 2 to both sides. If I add 2 to both sides, I get 10 and 8, right? Adding 2. This is the original. Can I still put the is greater than? Yep, still makes a true statement. Now I'm going to ask you to subtract 2 from both sides. The original. I get 6, I get 4. Can I still put the is greater than symbol? Yep, still makes a true statement. Watch, almost done, not done yet. Okay, I'm going to ask you to divide by 2. If I divide by 2, the original, remember, I get 4, I get 3. Can I still put is greater than? Yes, I can. Right, still true. Watch this, almost done. I want to divide by negative 2. That's going to be negative 4 and negative 3. Can I still put the is greater than symbol? No way. That makes a false statement. I got to flip it. So here's the deal here. Let's do one more. Let's multiply by 2. The original. I get 16. I get 12. Can I still put the is greater than? Certainly can. Still a true statement. Okay? Let's divide by, let's multiply. We're still multiplying. Let's multiply by negative 2. Multiply the original by negative 2. Negative 16, negative 12. What about now? No way, I have to flip the symbol. So here's what I now know. Whenever I multiply or divide by a negative, I have to flip the symbol. So here, because I divided by a negative, I divided by this negative 2, I must flip this symbol. That's why the answer here is x is greater or equal to negative 4. If I was to do this problem, how many checks would I have? I'd have 2 checks because there's 2 pieces. What would I have to check? I'd have to check negative 4 because I have to check what's equal. Right there it says x is all the numbers that are either greater than negative 4 or equal to negative 4. So I'd have to check negative 4, and I'd have to check a number greater than negative 4, so maybe 0. What will negative 4 do to it? Since it's the endpoint, it will make it equal. And we can see it does. What will a number greater than negative 4 make it? It will make it less than. Watch, let's check 0. Negative 2 times 0 is 0. 0 is less than 8. So you must have 2 checks if you have a symbol that has 2 pieces. So if your symbols are either is less than or equal to or is greater than or equal to, you have 2 checks. If it's this symbol or this symbol, you have 1 check, which is exactly what, when solving linear inequalities, what that little thing tells you that's in your workbook and on the slide. So you solve linear inequalities the same way you solve linear equations, the exact same way, except when you multiply or divide by a negative, you have to flip the symbol, and you have to be careful about the number of checks you get. Okay? First of all, the endpoint will make the 2 sides equal every time, and the number of checks depends on the inequality symbol. And that's what that solving linear inequalities slide tells you. And we'll do some more problems as soon as we get this board erased. All right, remember the deal here. We solve this exactly like we do in equals. I would not change this to an equals. Some people do and put it back. I don't think that's a good idea. So let's do this. Remember, before we move anything, we want to make sure we simplify either side. So on the left side, we can simplify these. I have 5 x's. I owe you 7 x's, so I owe you 2 x's. Oh, see? Now look what I did after I said I'm not going to do that. Greater than or equal to 2 minus x. If this makes it easier, you can put a 1x here. So that's a negative 1x. Now I want to get all the variables to one side, all the numbers to the other. Okay? I'm going to work with my variables first. So I'm going to add x. This is negative 1x is greater or equal to 2. Okay? Now I have to divide by a negative 1, but I'm dividing by a negative. So I have to flip this sign. X is less than or equal to negative 2. It's not because our answer is negative. It's not because, even if this was negative, it doesn't matter. What matters is this, what we're dividing by. And we're dividing by a negative, so we flip that inequality sign. We have x is less than or equal to negative 2. How many checks? Yeah, 2 checks. All right. When you check, you got to check in the original question. First thing we're going to check is x equals negative 2. Do you all know what that should do? That will, if you did it right, make both sides equal. So let's take a look. I'm not going to, after I check these two, I'm not going to check a whole ton more. I just want to show you. So wherever you see an x, we're going to plug in negative 2. 5 times negative 2 is negative 10. A negative times a negative is a positive 14. Is greater than or equal to 2 plus 2. Negative 10 plus 14. I owe you 10, but I have 14. So I have 4, which is greater than or equal to 4. That checks out. Remember, we said that will make it equal because we solved it as if it was an equal. The endpoint makes it equal. Okay? Now, we're going to check a number greater than, less than. X is less than, a real number less than negative 2. So I'm going to check, I don't know, negative 4. That's less than negative 2. I'll check it in this. I hope I have enough space. 5 times negative 4 minus 7 times negative 4 is greater than or equal to 2 minus a minus 4. This is negative 20 plus 28 is greater than or equal to 2 plus 4. Oh, did I screw up here? I'm checking negative 4, negative 20, negative 28, 2 minus... Oh, I'm supposed to be greater than. See, I'm thinking it's supposed to be equal. What a fool I am here. Okay, here we go. It works out because you wanted it to be greater than 6. It works out. So used to getting it equal, I forgot what I was doing. Okay, so that's it. That checks out. Okay, let's try number 2. That was all for number 1. All right, let's go to 2. Negative 3x plus 6 is greater than negative 6x plus 6. Okay, I like to start with my variables first. I add 6x. I add 6x. I get 3x plus 6 is greater than 6. I subtract 6. 3x is greater than 0. That's okay. Divide by 3. X is greater than 0. Can I check 0? No. I cannot check 0. You will get this wrong if you check 0. You have to check a number greater than 0, not 0. A number greater than 0. There's one check for this problem. I know you're doing a dance right now because there's only one check. I'm going to do the check right here. There's one check for this problem. And can't be 0 because 0 doesn't work. A number greater than 0 works. Do you see that? A number greater than 0. It doesn't say equal to. 0 does not work. So greater than 0, I'm going to check 5. Why? I have no idea. So check. I can check any number you want greater than 0. Okay. Negative 3x plus 6 is greater than negative 6 times x minus 1. Here we go. Check in 5, right? Negative 3 times 5 plus 6 is greater than negative 6 times the quantity, 5 minus 1. Let's do a little math here. Negative 15 plus 6 is greater than negative 6 times 4. Negative 15 plus 6 is negative 11, is greater than negative 24, and that does check. So you're done. Your answer is x is greater than 0. But you know what I forgot to do? It's okay. I'm going to do it right now, so hold on to your hats. A couple more things to say. If I had checked 0, what would have been true about the left side and right side of the problem? Yes, they would have been equal. And you don't want them equal. You want the left side greater than the right side. Does that make sense? You're supposed to say yes, but I'm talking to a camera. Okay, here we go. Let's take a look. We're supposed to graph this. X is greater than or equal to negative 2. Let's remember how to graph. Okay, here's 0. Here's negative. That's not negative 2. Let's try positive 2. Here's negative 2. Here's 3, here's some other numbers, here's 1 in there, you know, doesn't matter. Okay, less than or equal to negative 2. I am including negative 2, so I make a closed circle. Less than or equal to looks like this. Okay, to the left. X is greater than 0. You know there's positives on this side, negatives on this side. I want greater than 0, but I'm not including 0. Open circle on 0, open circle. Greater than, here are the numbers greater than 0. And there's your graphs. So there's your solve, your checks, your graphs. That's how you do it. It's an incredible thing. All right, let's do some more. Oh, you know what? Before the next one has a couple of problems on it, do those in your workbook, and then we'll come back and look at them. All right, let's take a look at this. You know, I've been working on the problem that I write. I'm going to hope, and we talked about this in a couple mods before, is to rewrite the problem that's in your workbook. First of all, it's kind of small in your workbook. Second of all, you want to know what the original problem is. I just have limited board space. You know what I mean. Limited board space. Okay, we're going to distribute 3u minus 3. Remember, once to distribute, let go of the parentheses. Minus 3u minus 3 is less than 2. Okay, remember we're going to simplify before we move. 3u minus 3u, that's gone. Negative 6 is less than 2. Okay, variable drops out. Remember this? This was from mod 4 or 3, can't remember, but it's been in the homework. Okay, negative 6 is less than 2. Our variable drops out. You stop. This is a true statement. So that tells me what solves this is all real numbers. It's called an identity. They didn't ask me what it's called. They asked me to solve it. Okay? And they asked me to solve each graph and write each answer in set notation. Okay. Set notation actually depends on kind of what you want to do, but set notation really is just a big R for all real numbers. Okay? And graph, I wouldn't want a graph for this, but this is a graph. You know, there's obviously numbers on the graph, and what solves it? Everything. But all real numbers solve it. That's it. Okay, and we can't check that. Why? Because everything checks. All right, so we can't check that. So we're done with that problem. That was kind of cool. All right, ready for the next one? Here we go. All right, let's take a look at this. Number one rule of thumb that I just broke is do not squish. Okay, here we go. LCD is 15. We're going to clear the fraction. There's a negative here. Be careful. 3 goes into 3 once, 3 goes into 15, 5 times. 5 times 2 is 10, times the quantity x minus 2 is greater than or equal to 3 times negative 4 is negative 12, times the quantity x plus 6. Here we go. 10x minus 20, distributing. It's greater than or equal to negative 12x minus 72, distributing. Add 12x. Add 12x. We get 22x minus 20 is greater than or equal to negative 72. Add 20. I'm laughing because I know what's going to happen. Okay. 22x is greater than or equal to negative 52. This is not going to come out nicely. We are not dividing by a negative. We do not flip the inequality symbol. We're going to just reduce this. This is negative 52. Divide that by 2. 2 goes into both of those. So x is greater than or equal to, this is what I'm doing. I'm dividing this by 2, dividing this by 2. What is that? 26/11. And it is negative. So the answer is negative 26/11. How beautiful. You know why I'm standing here like this? Because we need to check that. And how many checks do we need to make? Oh, by gosh, it's 2. Okay, 2 checks. We need to check. So the answer is, I'm going to put it here for a minute because I want more space over there. That's the answer. We have to check that, glory be. And then we have to check a number greater than that. That's going to be easy because the number greater than that, I'm going to check 0. That's going to be nice. Okay, so I can check 0 if I want. That's not a big deal. That negative 26/11 is going to be a little work here. The check is actually harder than the problem, but we're going to do it. Okay, here we go. Checking negative 26/11. All right, 2/3 times x minus 2. Write the original problem. Negative 4/5 times x. I know I'm going to have to erase some of this and get you more space, but we'll deal with that when it comes to it. X is negative 26/11. I'm going to write the 2 over 1 because I'm going to have to combine them. You're feeling happy. All right, here we go. Greater than or equal to negative 4/5 times negative 26/11 plus 6 over 1. Oh, I'm feeling happy. You just can't tell yet, but I'm happy. Okay, now Order of operations says combine, parentheses first. 2/3, here we go, negative 26/11. The common denominator is 11. So multiply this by 11, multiply this by 11, that's 22/11, right? Because 22/11 is 2, right? Makes sense, cool. Greater than or equal to. Feeling better? I'm feeling better. I'm feeling better. Here we go. Negative 4/5 times negative 26/11 plus, making a bottom 11, multiplying by 11, multiplying that by 11, we get 66/11, because 66/11 is 6. Kind of cool. All right, here we go. I owe you $26, I owe you $22, I owe you, I don't really care what I owe you. No, I owe you 48/11. This is greater than or equal to, and by the way, what is this supposed to make it? Do you remember? We're checking this. It's supposed to make the left side equal to the right side if we do it right. Negative 4/5. I owe you 26, but I have 66, so I have 40/11. Here we go. 3 goes into 3 once, 3 goes into 48 16 times. That is negative 32 over 11 is greater than. 5 goes into 5 once, 5 goes into 48 times. 8 times 4, 32/11. Oh my gosh! Jump up and down, it's time! Jump up and down. That's one check. We got to do another one. Okay, so we want a number that's greater than this negative. Pick 0. 0's easy. So now I'm going to check this for 0. You ready? Here we go. I'm feeling it. Are you feeling it? All right. So now we need a number. X has to be greater than or equal to negative 26/11, and I'm picking 0. Why? Because 0's easy. That's why. Don't be silly. Okay. 2/3 x minus 2 is greater than or equal to, I'm going to dream about this problem tonight. Okay, here we go. 0 minus 2 is greater than or equal to negative 4/5 times 0 plus 6. 2/3 times negative 2 is greater than or equal to negative 4/5 times 6. Whoa, this is so much easier. This is negative 4/3 is greater than or equal to negative 24. Well, is it really easier? Do you really know? Do you know? Can you say, yes, that's true, I know? Well, I'll tell you what I would do. I would change this to a silly mixed number and see. This is negative 1 1/3, and that's supposed to be greater than or equal to negative 4 4/5. So yes, I know it is greater, right? Because this is more negative. So I would have did that. I wouldn't worry about getting a common denominator. I would just change it to a mixed number. So that is true. I am done. We've checked it. We've done it. Oh my gosh, nothing left to do. Okay, there are 3 left, and they're for you. Okay, so, oh, you know what? One more thing. It kind of said to write this in set notation. I have to be honest, this for me is good enough. This was the answer to this problem. That for me is good enough. X is greater than or equal to negative 26/11. I believe for my math lab that is also good enough. But some people want you to write the whole thing like this. Not me, but it's possible. But this is good enough for me. But this is the same thing. Okay. At any rate. Okay, so that's that problem. There are 3 left. They're for you. Click off the video, start them, try them, and then click back when you're ready. Tell me why I was extremely nice to you with your checks. Each one of these only needed 1 check. I'm going to leave the check to you, but I'm going to do these problems. I owe you 3y, I owe you 2y, I owe you 5y, plus 10 is less than 7 minus 8y. I like to work with the variables first. I'm going to edit, and I have the chalk, so I'm allowed. Well, it's not really chalk. You know what I mean. So this is 3y plus 10 is less than 7. Subtract 10, subtract 10. 3y is less than negative 3. Divide by 3. Do I have to flip the symbol? The answer is no. I didn't divide by a negative. I divided it into a negative. Who cares? Y is less than negative 1. That's fine for me for set notation. You might want to see this. Same thing. Same thing. I don't care. But we do want a graph. y is less than negative 1. So here's 0, here's negative 1. You want less than, not including negative 1. Open circle, less than, this way. Done. Check's up to you. You cannot check, important, you cannot check negative 1. Negative 1 will make both sides equal. It can't be equal. You've got to check a number less than negative 1, so maybe negative 8. And negative 8 will make this side less than this side. That's the whole point, because it says less than. All the real numbers less than negative 1. Oh, and the reason this is a y and not an x is because this is a y. It has to be the same variable. Glad you asked. Okay, number 2. Ready? All right, we need to get rid of the fraction. So I'm going to multiply by 4, and we get negative 3x is greater than 32. Divide by negative 3. Yes, we're dividing by a negative, so we must flip the symbol, and we're going to get, that's it, we're going to get negative 32 thirds. Why am I not going to change it to a mixed number? Because if I check it, I have to check it as a fraction. Actually, I'm not even sure I want to check it because negative 32 thirds, actually, to be honest, if I had this and I had to check this, if, this is in my head, if I had to check this, this is negative 10 and 2/3. I would just check negative 11 because that's less than, you get that? So that's pretty cool. But anyway, that is your answer. If I want to graph that, here is the graph. Here's 0. Here's like a 1. Here's that. Negative 32 thirds. Don't go crazy. You don't have to make thirds out of it. I want less than. I'm not including it, so it's less than. Now, if I pick negative 11, which is less than that, and I check it, I don't check that because it doesn't say equal to. If I pick negative 11, it's going to make this side greater than 8. Okay? That's what it's going to do. All right? In fact, I'd probably pick negative 12 because that will reduce easily. Whatever makes you happy. Okay, you ready? Here we go. Last one. Subtract 3, subtract 3. Remember when we do this, we still have to put the bigger number on top and subtract. We know our answer is going to be, negative because we owe more than we have. And this answer is 0.9, right? Because we have to borrow 0.9. So we have negative 0.06x is greater than negative 0.9. Now we have to divide. We're dividing by a negative. Uh-oh. When we divide, remember we have to move the decimal. It's going to be a positive answer. I might want to remind you of that. And now we're going to go 0.06. Let's do this kind of quick. Into 0.9. We move it here twice. We move it here once. So twice, once for there, and then we need another place, sorry. So it's just like 6 into 90, which is 15. So x is greater than 15. How many checks? Oh, what'd I do? What'd I do? I divide by a negative, didn't I? I had to flip the symbol. So x is less than 15. So I have to pick a number less than 15 to check. I cannot check 15. Less than 15, so maybe 10. If I check 10, it's going to make this side bigger than 2.1. Okay? So that's the end of that. That's how you do it. Kind of cool. A little annoying, a lot of little algebra, arithmetic, but not too bad. All right, next problem as soon as we come back. All right, it's time to revisit that challenge question. It's Mark, and he wants to join the National Honor Society, but his average has to be at least a 90. Okay, what does at least a 90 mean? Remember, at least, if I have at least 90 bucks, it means I have to have greater than or equal to 90. Okay, that's at least a 90. Well, how do you take an average? Well, you add up all the numbers and divide by how many numbers there are. So let's take a look at the numbers. We have 86 plus 91 plus 89 plus 93. But you want to know what he gets on his fifth test. Fifth test. I have no idea. That's why we're doing this problem. Okay, so plus that fifth test, divided by 5 because there are 5 tests. Okay, right? It's one test. Yep. Okay. And we want that to be greater than or equal to 90. That's the problem. So here we go. We can do this. We can add these numbers up. When we add those numbers up, we have 359. That's all of these numbers added together. Plus x over 5 is greater than or equal to 90. So that's what I have so far. That's the problem I am solving. Now that I wrote so big that I can't really fit anything else, I'm going to recopy that up top, okay? Then erase the rest of the board so you can follow me. I was just such a cool problem. It was on a flow. Okay, now for me, I would like to do this as a fractional inequality, not an equation, but again, you solve them the same way. So we're going to multiply this by 5. We're going to multiply this by 5. If I do that, good night, and we get 359 plus x is greater than or equal to 9 times 5, 45. Put that 0 in. Awesome. Subtract 359. Subtract 359. X is greater than or equal to 91. Right? Right. 10 to 1, can't do it. 3, sure. 91. So it says, what is the minimum score you can get on this last test? Well, what is the minimum? He's got to get greater than or equal to 91. The minimum test score, the minimum test score. The minimum test score is a 91. That's the minimum. He needs at least a 91 to get an A average. And there's Mark. All right, should we try another one? Because I know you love those. All right, let's try another one. All right, here we go. We have a rectangle whose length is 18, and we want to know, whose length is 18 inches. We want to know the width if the perimeter is at most 50 inches. Here's the keyword, at most. At most means we have an inequality. So we know perimeter is at most 50. Is at most. Okay. So perimeter, first of all, to get the perimeter, we have to add up all the sides. So let's call this x, this question mark. So we have 18 plus x plus x is at most. If I have at most $50, it means I have less than or equal to 50. That is at most 50. This is 2x plus 36 is less than or equal to 50. Subtract 36, subtract 36. 2x is less than or equal to 14. Divide by 2. We divide by a positive. Don't worry about the symbol. X is less than or equal to 7. The question says, what is the maximum value for the width? Maximum value, it's got to be less than or equal to 7, so the maximum value is 7 inches. So maximum value, 7. So just look for the keywords. Keywords will make this easy. Is at most, is at least, not more than. All those means those inequality symbols. Okay, let's take a look at the next question. All right, here we have Jane, and she's hired to deliver Christmas trees for a day. I hope it's Christmas time. Anyway, she agreed to accept $50 for the day, plus $12 for every tree she delivers. Okay? What is the minimum number of trees she needs to deliver to make at least $182? Okay, this is something like we did the other day, where we talked about making our own formula. This is what we know about Jane. She's $50 for the day, $50 plus $12 for each tree, and she wants to make at least $182, that's a strange number, but $182. Okay, so here's what we know. We want to know how many trees she must deliver. We don't know that. We don't know how many trees she must deliver. So it's $50 plus, here's what I know, $12 for each tree. So if the trees are X, $12 for each tree. If there's one tree, she's getting $12. 2 trees, 12 times 2, $24, okay? And she wants to make at least. At least means greater than or equal to $182. That's the way that looks. Kind of cool? Kind of exactly like we did the other day. I think we were renting a car yesterday. I can't really remember. Okay, or the last lesson, whenever we did it. Okay, 12x is greater than or equal to 132. Divide by 12, divide by 12. That's 11. 11 trees. Greater than or equal to 11 trees, but what's the question? What is the minimum? The minimum is 11 trees. Okay, that takes care of that problem. Let's look at the next problem. All right, Mark needs to find a job, but let's do this problem. Mark earns a yearly bonus of 1.6% of all sales he makes in excess of $82,000. So if he sells $82,000 worth of stuff, he gets no bonus. Okay? Now, determine what Mark's annual sales must be in order to earn a bonus of at least $1,800. So this is what I know. I'm going to let X, and the reason I'm writing this down is because I don't want you to forget what X is. X equals the sales above 82,000, because that's all that this guy makes any money on. Okay, and here's what he makes. He makes 1.6% on sales above 82,000. Okay, and we want that to be at least 1,800. That's what we want. Okay, so 1.6%, we have to change that to a decimal. Remember, D to P, we have to move it 2 places to the left. So that's 0.016 on sales above 82,000. We're going to call that X. Now, that's going to be interesting when we're done, okay, because that's not going to be our answer when we're done. We'll talk about that. And you want that to be at least 1,800. Okay? So now all we do is divide by 0.016, and I know by now you know how to divide by a decimal. So X comes out to be greater or equal to $112,500. Think about what that is. Think about what you want. That's his sales above 82,000. You want his yearly salary. Mark's annual sales must be. So you want his annual sales. That's the sales above 82,000. So this is step 2 here. Step 1 is to figure out what his sales above 82,000 is. Now, there was another way to do this problem, but I think it was a little harder. Okay, so now I have to take 112,500 and add it to 82,000, because remember, he got nothing for that. Nothing. Okay. He has to make $194,500 a year. Yeah, right. But that's how you do that problem. All right. Let's go back to Mark for a second. We just said his annual salary was that big number. That was actually his annual sales. So sorry about that. Okay, let's check this one out. This one's a little easier, I think. Find all such numbers such that 7 less than twice a number is between, that's the key word there, between 0 and 9. That tells me that I'm going to use that, that compact form. Smallest number first. Everything points left, variable in the middle. Well, what truly is the variable? Let's talk about that. It says find all such numbers such that 7 less than twice a number. That's what's between there. 7 less than twice a number. That's what's between it. So less than switches the order, so twice a number goes first, minus 7. So that's what goes right here. Okay. Now, there's a couple of different ways to think about how to solve this. One way is we could break it up. I don't like that idea. I'm going to solve this just like this. Think of this. Remember, an inequality is solved the same way as an equation is. Think of this. Make 2 lines, dotted lines going down. Think of this inequality, or should I say double inequalities, having 3 sides. So whatever you do to one side, it's got a left side, a middle, a right side. Whatever you do to one side, you have to do to the other side. Okay? So here's what we're going to do. If you didn't have this, which way can I do that? If you didn't have this and you just had 2x minus 7 is less than 9, what would you do to solve that? Well, you'd add 7. Well, you do that now. Add 7, add 7, add 7. Okay? And now I would get 7 is less than 2x is less than 16. Now again, if I didn't have that, what would I do to solve that? 2x is less than 16. I divide by 2. Well, if I divide by 2 here, I'd have to divide by 2 here. I'd have to divide by 2 here. So I'd get 7 halves is less than x is less than 8. That's my answer to this question. Now, be careful. It says find all such numbers. That's nice, and you might understand this to be all the real numbers between 7 halves and 8, but maybe it'd be a little easier if we explain that this is 3 1/2. So this is all the real numbers. Find all such numbers. It's all the real numbers. I'd like to say it. Didn't ask you to, but it makes more sense. All the real numbers between 3.5, and 8. And of course, it's not including either one, so that's all you have to write. So that's the answer to that question. So that word between tells me about this compact form. Smallest number first, variable in the middle, and every inequality pointing left. And that's it. So let's try some more of those. All right, this is double inequality, compact form, but it's got a fraction in it. Now you have a couple of choices. We want to solve this, and I'm going to do this thing with the double line here so we know the 3 sides. You can either get rid of the 2 first, but the way we do fractional inequalities or fractional equations, we just clear the fraction right away. So that's what I'm going to do. If you want to get rid of this 2 first, you can. We're going to multiply by 2 because that's the LCD. It's got to be every term. Every term. Okay, and we get 16. Now I'm going to get those dotted lines out of the way a bit. 16 is less than or equal to 3x plus 4 is less than or equal to 30. Okay, now, if I didn't have this, I'd subtract 4 from all the sides, here, here, and here. 16 minus 4 is 12, is less than or equal to 3x, is less than or equal to 26. Now we're going to divide by 3, we're going to divide by 3, we're going to divide by 3, and we get 4 is less than or equal to x is less than or equal to 26 thirds. The reason I'm leaving it here as 26 thirds is because your question says solve, check, graph. Write your answer in set notation. You can either leave it like this for set notation, or you can use the braces with the x in the front. Either way, but we need to talk about this. You know how many checks this has? 3. This actually has 3 checks. I'm not going to do all the checks. In fact, I'm not going to do any checks. I'm just going to make you understand that it has 3 checks. You have to check 4, because it says it equals. 4 will make, okay, 4 will check in this equation. Inequality, this inequality. You'll have to check 26 thirds. It will also check. And you have to check a number between 4 and this. This number is really 8 and 2/3. So you'd have to check a number between 4 and 8 and 2/3. Maybe you want to check 8. Maybe you want to check 6. But this actually has 3 checks. What it's equal to and a number between them. So it actually does have 3 checks to this problem. Okay? So I'm going to ask you to do 1 and 2. You don't have to do the checks, but just tell me how many checks there would be in 1 and 2. Okay? So do the problem and just state how many checks there are, and I will check one of them. Okay? All right, let's take a look. I tried to give you the easy ones. That's why I gave you number 3. I did number 3. Okay, let's subtract 7, but then we have to do it here. We have to do it here. 12 minus 7 is 5, is less than x, is less than 16 minus 7 is 9. Okay, so that's all the real numbers between 5 and 9. If I want to graph these, oh, I forgot to graph that third one. That's okay. You can put that graph in, but I'll put this one in. Remember, never, never, ever, ever graph an x. Here's all the real numbers between 5 and 9. Open circle, close it up. There's your graph. If I wanted to check this, do you know how many checks? 1. All the real numbers between 5 and 9. I can't check 5 because it doesn't have equal to. Can't check 9 because it doesn't have equal to. I just have to pick a number between 5 and 9. Okay, so maybe like the number 7, okay, or whatever. Okay, I'm going to check that for you rather quickly. Okay, so check x equals, I don't know, 6, 7, 5.5. Why would I do that? Okay, 12 is less than x plus 7 is less than 16. 12 is less than 6 plus 7, which is less than 16. 12 is less than, oh yeah, that's right, less than. Oof, I'm losing my mind. 12 is less than 13 is less than 16. That's true. 2 reasons. I'll give you the 2 reasons. 13 is between 12 and 16, right? 13 is between 12 and 16, and 12 is less than 13, and 13 is less than 16. So that checks out. So that is the check. There's 1 check, just a number between there. Okay? Let's take a look at this one. A little harder. I have to add 4 to every place, every side. Don't leave a side out. It won't stay in balance. Okay, divide by 7. Divide by, look how nice, but you're not getting fractions like me. 0 is less than or equal to, x is less than 2. So all the real numbers between 0 and 2, including the 0. To graph this, 0, here's 2 if you want. 0 is included, we color it in. 2 is not included, and all the real numbers between there. There's your graph. How many checks? Take a guess. Yes, 2. There's 2 checks. We need a number between here, and we need 0. We need to check 0. What will 0 do? 0 would make it equal to one of the sides, and it does. 7 times 0 is negative 4, because remember, the end point makes you equal, okay? So that's how you do these problems. They're really kind of, I think they're kind of simple, okay? They're definitely easier than the word problems. So if you want to do the checks, there's 2 checks. You might want to pick the number 1 to check, and you have to pick the number 0 to check, okay? And that's it. And that takes care of lesson 10. Wow, that's it. New mod next time.